Okay, welcome back to another Physical Sciences 3 lesson. We are on page 42 and we are looking at example 14 where we have a car of mass 1.2 tonne towing a 600 kilogram caravan. If the car accelerates at 1.5 meters per second squared westwards, find the horizontal force exerted by the road on the car's tyres. Okay, so we have a 1200 kilogram car, 600 kilogram caravan. Let's draw that. So we have, this is my car. Ooh. Okay, that's my car with a small boot. And we have the caravan here. Alright, so the caravan's being pulled along by the car. This is a 600 kilogram caravan and this is a 1200 kilogram car. So the forces happening here, we have the car pushes against, so I'm just going to say it's front wheel drive here. So we have the car pushing against the road this way, and we have the road propelling the car. It's a weird concept, but the road is actually pushing the car forward due to Newton's third law with equal and opposite forces. Okay, so they are the equal and opposite forces, and so because this car is pulling the caravan along, all that force is going through the car as well. So the force of the road on the car is equal to the net force of the entire system. And what I mean by system is it's the caravan plus the car. So it's equal to 1200 plus 600, the mass, times by the acceleration of 1.5. So 1800 times by 1.5, which is equal to 2700 newtons west. So the car is pushing, the road is pushing the car west, and that is our positive direction. We should define that. Okay. So there's hair on the screen. So okay. The force the car exerts on the caravan. Force that the car exerts on the caravan. So in order for the car to move the caravan, let's go with red. So we have equal and opposite forces F of the, so this one here is the car is moving the caravan forward. So and just saying that the F of VC. Okay, so these are also equal and opposite, where the force of the CV is the car on the van, and the other way, VC is the force of the van on the car. Okay, so in order for the car to move the caravan, it's equal to the mass of the car. I mean the mass of the mass of the caravan, which is 600 times by the acceleration of the caravan, which is going to be equal to 900 newtons, and the caravan moves west as well. Okay, so the car must have put a force of 900 newtons west, and that goes through like the coupling of the tow. The force that the caravan exerts on the car, so this is by Newton's third law. By Newton's third law, the force of the van on the car is equal to negative the force of the car on the van, which is equal to negative 900 west, which is equal to 900 east, which makes sense. Okay, so the force, so the caravan is resisting the motion of the car. So the net force acting on the car, so let's just draw the car by itself and look at the forces that are acting actually just on the car itself. think my car has changed shape slightly. So we have, let's have a look at our, so on our road we had the force of the road acting on the car, and then we also have the force of the van acting on the car. So we have the road propelling the car forward, and then the force of the caravan resisting that motion. So F net of car is equal to the force of the road of the car minus this force here, which is equal to 2,700 take away minus 900 newtons, because it's 900 east, so it's equal to 1,800 newtons in a west direction. Okay, and if you just calculated, if you just looked at the car in isolation and calculated its mass, which is 1,200 times by 1.5, it is the same as 1,800 newtons west as well. So we can corroborate. So still F net equals MA still holds true for that if we look at it in isolation.